Let's have a look at differentiation. Supposing you have an equation in this form and you need to differentiate it. You have an equation in this form: ax raised to m plus bx raised to n plus cx plus d, and you need to differentiate it. This is how you do, or how you go about it. The first thing, let me have this d, or this x raised to 1, because when it's raised to 1 we don't write it as 1, but let me write it here first. And on this d I can write as d x raised to 0, because any number raised to 0 is 1. Any number raised to 0 is 1. So this is how you do, or you go about it. You take the degree of m, you multiply by a. Take the degree of m, multiply by the coefficient of x. So this one will be am, then x. On this degree you subtract 1, so it will be amx m raised minus 1 plus, take n, multiply by b, and here you subtract 1, so it will be bn x n minus 1, then plus, take this one, the degree of this x, which is 1, multiply by c, then here you subtract 1, so it will be c, because this one it will remain x minus 1, which is x raised to 0, and n number raised to 0 is 1. When I come here, I take 0 multiply by d, it is rendering this thing 0. So differentiation of a constant is just a 0, so we don't write that 0 there. So this is how you do it. Let's have an example. Example 1. Example 1. Supposing you have an equation 2x cubic minus 3x squared minus 12x then plus 12. Let's differentiate that equation. We still just use the same procedure to go about it. Take the degree of x, which is 3, you multiply by 2, so this one will be 6x. Here we subtract 1, so it will be 6x squared minus 2 multiplied by 3, that is 6x. Here we subtract 1, it will remain 1, so we don't write there. We have 1 multiplied by 12, it is just minus 12, because this is x now raised to 0, we don't write there, any number raised to 0 is 0. When I differentiate a constant is 0, so this remain my answer. That is how easy someone can differentiate, or that's how easy you can differentiate an equation.